Alright, this video is going to contain the solutions for 2009 AB number 3. We've got the Mighty Cable Company. It's a manufacturing cable that sells for $120 per meter. So you buy 6 meters of cable, it's going to cost you $720, for example. For a cable with fixed length, the cost of producing a portion of the cable varies with its distance from the beginning of the cable. Mighty reports that the cost to produce a portion of cable that is X meters from the beginning of the cable is 6 times the square root of X dollars per meter. So this is a rate. So the big thing for that we need to know in these kind of contextualized fundamental theorem problems is that the integral of a rate from wherever to wherever, x1 to x2, is the change in the amount of stuff that this is the rate of, right? Just like, I mean, velocity and displacement is the sort of paradigm example of this. If you take the integral of velocity, it gives you displacement, x, the change in position, in other words. So what that means is that since this is a rate, if we take the integral of this, that's going to give us like the change in the total amount of dollars, or in other words, the cost of making it from wherever to wherever. So, and then profit, we know what profit is. It's the amount of money you take in minus the cost. All right. So part A, find Mighty's profit on the sale of a 25-meter cable. So the revenue, money that we're taking in is just $120 times how much cable, how many meters. And the cost, like we just talked about, is the integral from 0 to wherever. Really, like technically, you would have to put, if you wanted to make it as a function of x, I would put the x here, and then because I used the x there, I'd have to put a t here. I don't think that that's something you should need to stress out or fret about at all, but you just really, you're not supposed to use the same variable for two different roles. So that's all. And then profit is equal to revenue minus cost. Amount of money you take in minus the cost of doing it. So what's our profit for, what did they say, 25 meters of cable? Excuse me. Is 120 times 25, right? That's the amount of money that somebody's going to have to pay for that cable. And then to find the cost for us producing it, that's the integral from 0 to 25 of R6. Now that I have a number there and not the x, I can switch back to x if I want to. If you put t's there or any other letter, doesn't make it wrong. So I need to do that, and this is a calculator active problem, so I'm not going to do that by hand. It's possible to do it by hand. It's a doable integral, but why would you when you got your calculator active? Minus, I'm going to try to make it look exactly like this, minus math 9, going to go from 0 to 25, that's 6 times the square root of x dx, that looks good. And that's 2,500, this is dollars. American dollars, I think, not Canadian dollars. All right, part B. Using correct units, explain the meaning of this in the context of the problem. Okay? So we already talked about if you're taking the integral of a rate, then you are finding the amount of change of this. So this is and they're not asking us to find out what it is, are they? Yeah. So this is the cost of making the 25 to 30 meter portion of the cable. and that they said use units. That would be in dollars. The other way you could explain it is it's the difference between, you could say, since this integral from 25 to 30 is equal to the integral from 0 to 30 minus the integral from 0 to 25, right? Just by basic sort of geometry of that. If you want the area from 25 to 30, you take the whole area from 0 to 30 and then subtract off 0 to 25. You have to picture that, how that works. This is the cost of making a 30-meter cable, and this is the cost of making a 25-meter cable. So you could say that it's the difference between the cost of a 30-meter cable and a 25-meter cable. There are two ways to answer that. All right. Part C, what do we want here? Write an expression involving an integral that represents Mighty's profit on the sale of a cable that is k meters long. Oh, I kind of have that all set up to do that here. So the profit, I'm just going to rewrite this here, is revenue minus cost. So the profit on a cable that's k meters long is the revenue, which is 120 times k, minus the cost, which is the integral from 0 to k of that. That was easy. Kind of set myself up for that already, I guess. And then part D, find the maximum profit that Mighty could earn on the sale of one cable, and then justify your answer. All right. So just trying to find the maximum of that. So to find the max of p of x, find p prime of x and set it equal to 0, right? That's how we find maximums and minimums. So let's do that. So p prime of x is equal to, imagine this with the x's in there instead of the k's. So if that's 120x, when I take the derivative of that, that's 120 minus the integral here. When you take the derivative of an integral, those things just cancel out like that, right? Derivative of integral, they go away. That's fundamental theorem. Now looking for where this is equal to 0. So 120 minus 6 times the square root of x equals 0. How are you going to deal with this? You're going to use your calculator. You could. This is just a little bit too easy to do without calculator, I think. If I do that, divide by 6, square both sides. So x is equal to 400. I just want to make sure that this is in fact a maximum. Does this derivative change from positive to negative at 400? So we could, let's see. So when you plug in something below 400, like 0, then sure enough that's positive. And if you plug in something above 400, like, I don't know, what's another nice square, 1,000, let's say, then that'd be 120 minus 600. That's definitely negative. So p prime goes from positive to negative at x equals 400. So that is a maximum, which is what we're looking for. Now they asked for here in the question, they didn't ask for how many meters of cable gives a maximum. They asked for how many, what's the actual maximum profit. So what's the actual profit at 400? That would be plugging 400 into this, to our profit equation. 120 times 400 minus the integral from 0 to 400 6 square root x dx, and just going to do that in my calculator again. So I want the same expression as this, 120 times 400 minus the integral from 0 to 400, 6 square root x dx. And that is $16,000. Not bad for a day's work. Well, assuming you can make a 400-foot cable or 400-meter cable in a day. There you go. There's that one.